about is continuity. And this is in your textbook, so just kind of look up at the screen for right now. I don't want you guys to try to write and pay attention at the same time. You could copy this out of your textbook later. But what I want you guys to understand is continuity. Now, continuity of a function is basically, are all the x and y values defined? Is it a curve that doesn't stop? Does it continue? All right. So let's look at this. If I look at this graph right here, if I were to sketch this graph, and that's what we're going to do, this is a great way to determine if something's continuous. So see this graph? I'm going to sketch it. So I've got my XY plane. Okay. And I'll use a marker so you can see it. So now if I were to sketch this graph, watch what I do with the marker. I'm going to come down. Did I lift my marker off of the paper? Not a single time. So that's continuous. Okay, that's an informal way to kind of determine if something is continuous or not. So now let's do the next equation, or the next graph. So again, I'm going to do the same thing. I'm going to try to sketch this graph. So I'm going to come right next to it, and I'll draw my XY plane. Now here is the thing. I come down and around, and I get right here. And I'm going to lift up my marker and sketch it. So right there's an issue. And I'm going to put an open circle to let me know that I have not defined that. Now, did I remove the marker? Did I have to lift it off of the paper? I mean, technically I didn't have to, right? I could have just drew the circle in right there. But I mean, it's not a continuous function, right? It's not defined all the way across for all the x values and all the y values. Does that make sense? Now this one is what we call a removable discontinuity, because I can make the function continuous by plugging the hole somewhere. In other words, I could define this point here, right? Or I could even define this point here through like a piecewise function. So I could say like f of x is g of x less than a, right? And I could call this point here A, and then I could say h of x at A, and then I could define it after A if I wanted to. Okay, does that make sense? So this one's called a removable discontinuity. All right, here's another type of renewable discontinuity. However, in this discontinuity, we didn't plug the hole at all. So clearly that's discontinuous. Right at A, when x equals A, there is no value for y. Now, the next one is what we call the jump discontinuity. And what it is that the function jumps. That's why we kind of label it the jump discontinuity. So as you go across the domain, for every x, there is a corresponding y value, but it jumps. In other words, here y approaches 0, but then it jumps up above 0. Okay? So if I were to graph this and I came down and around, I'd have to lift my pen off the paper to get to the next point. Right? And then lastly, it's just like the previous example that we did, and this is called an infinite discontinuity. This usually occurs like in our previous problem where you have a rational expression, a fraction, that has an x in the bottom, and because there's an x in the bottom and we can't let the bottom equal 0, there's a vertical asymptote. And so wherever the vertical asymptote occurs, usually there's an infinite discontinuity. Okay? So the reason we want to know about discontinuities is because it's very important for calculus. And so we're gonna look at all these definitions real quick. Again, if we come up to the top, I just want to show you these graphs again so you guys could see them clearly. Okay, this is continuous, right? And so I'm going to cover these up. We're going to cheat a little bit. Okay, that's a continuous function, yes? All right, now watch this. Is that continuous? No. Does anybody remember what we call that? Removable, right? Because some textbooks will call it pluggable, because you can plug the hole. Okay, here's another one. Is that continuous? Oh, showed you the answer. Oh. Clearly that one's not continuous. What kind was it? Removable, right? So let me show you the next one. Is that continuous?
No.
No. What do we call it? Jump discontinuity. And the last one here, is that continuous? What do we call that one? What do we call it? Say it with passion. Like you just love to do this stuff at 7:45 in the morning. Or 8, or whatever time it is. What is that? It's approaching infinity. It's an infinite discontinuity. Okay? It's an infinite discontinuity.